Hey guys, today we are going to discuss this problem. It's say 1800, and as always, we are going to start with the example here. So their example is way too complicated, and the second example is way too simple. So I design our own example here. So um, the first line is the number of stations, right? Uh, Sorry about that. So this number is the number of stations. So for this example, we have five stations, right? And we can move from one station to another, right? We can only move from one station to the next station, right? And it forms a circle. Um, and the second number is the number of candies. So each candy has a start point and an ending point, right? For the first candy, the start point is 2. So we use plus sign as the starting point. And the ending point is 4, right? We use minus sign. And for the second candy, the starting point is 2. Ending point is 5. For the third candy, the starting point is 3. And the ending point is 1, right? So our goal here is to move all of the candies from the starting point to the ending point, right? And we are going to have a train to do that. So let's say the train starts from the first point and it move along the circle. And first is here, second is here, and here he can pick up one of the candies in this station, right? He can only pick one candy. And he can drop off any candy, right? There is no limit on the on how many candies the train can hold, right? The train can hold any number of candies and can drop off any number of candies, but it can only pick up one candy at one station, right? So let's say the second at of one thing need to mention, we need to calculate the um, shortest time cost for the train to move all of the candies from the initial point to the ending point, right? So the time cost for the train to move from one place to another is 1. So if we move the train from 1 to 2, that's a 1 second cost, right? And it doesn't cost any time to uh, load and unload those candies, right? So essentially, we need to calculate the minimal distance the train has to cover to move all those candies to the right place. Uh, let's take the example here. So the first output is the shortest distance the train need to cover if the train starts from the first station, right? And the second output is the minimal cost starting from the second station, right? So let's take the first station as a example. So it moves from the second station first, and the time cost here is 1. At the uh, s- second station, it picks up, uh, let's say, candy number 2, and it move along to the next station. Time cost now is 2. To the next station, time cost now is 3. To the next station, time cost now is 4. And then now we want to drop off on candy number 2, right? And time cost 5, 6. Now here we need to pick up another candy, right? And move along 7, 8. Uh, at this point, we need to drop off this candy number 1, right? And we forgot to mention one thing. When we move from the second candy to the third, we need to pick up the third candy as well in the first circle, right? And when we move along, um, 1, 2, 3, 4, we drop off for the second candy. 5, we drop off the third candy. 6, 7, 8. So the total cost is 8, right? If we started from the first station. So let's take a look at the case where we start from the second station. So first we pick up, let's say we pick up 1 this time. So 1, 2. So at this station we pick up 3, right? 2, drop off 1. 3, 4, drop off 3. 5, 6. Yeah, here we need to pick up 2. 7, 8, right? The total time cost is 8. But here our output is 7. Why? Because it is not the optimal answer, right? So let's, last time we pick up 2 first, so this time we pick up 1 first. Let's try it again. So starting from this point, we did pick up 1, 1, and pick up 3, 2. Actually, last time we pick up 1 first, right? So this time we pick up 2 first. So 2, 1, pick up 3, 2, 3, drop off 2, 4, drop off 3, 5, 6. Here we pick up 1, 7, drop off 1. So we got the this time we just use 7 seconds, right? So 7 is the optimal answer here. So that's it. How do we solve this problem? So the way we solve this problem is to first simplify this problem. So because we need to calculate the overall optimal, right? So that means we need to calculate the optimal to move one station's candies to the right places first and calculate this value for each of the stations, right? So first, let's calculate what is the optimal time cost to move all of those candies in station 2 to the right places. So in this case, let's see which candy we need to move first. So the optimal choice is obviously choose the further candy first, right? So in this case, if we want to move candy number one, we need to cover two distance, right? And if we choose to move candy number two, we need to cover three distance, right? So obviously we want to cover candy number two first. The reason is that each time we can only pick up one candy at a station, so that after that we want to drop off that candy, but we need to move a full circle anyway to pick up another candy from this station, right? In this case, we it, for those candies before the last candy, it doesn't matter how long is the distance, we always need to cover the full circle. But for the last candy we pick, we don't need to go the full circle. We only need to cover the distance that candy has, right? So if we pick up candy number one last, we for the last candy picking, we only need to cover two distance, right? But if we pick up candy number two last, we need to go all the way up to here. So that's not the optimal. So that's the greedy part for the solution, right? If we want to move one station's candy to the right place, we need to move the candy with a longer distance first and leave the shortest distance to the last, right? And we are going to calculate this value for all of those stations. And the longest distance is the output we are going to use, right? Because the maximal time cost for each of those stations is going to be the final answer. So with that being said, I think we already described the critical parts of the algorithm. So let's take a look at the code here. So first, we are going to read the number of stations and the number of candies. And then we are going to read all of those candies, the starting point and the ending point. And then based on the starting points, we are going to update the station's two values. We are going to calculate two values for each station. The first value is the number of candies in that decision, in that station, right? So in this case, we have two candies at the station 2, right? So the first value for station 2 is 2 in this case, right? Then what is the second value for for each station? The second value is the minimal distance in that station, right? Because we're going to cover the uh, minimal distance last in the last circle, right? So we only need to know for all of those candies in that decision, which candy is has the nearest ending position, right? So for each candy, uh, we are going to update the second value in that decision, in that location, right? If the if this is the distance between the starting point and the ending point for that candy, and we are going to use that distance to update the second value of the station. And the second value of this station is the minimum of those distance, right? And after this part, we are going to have the number of candies in each station, and we are going to have the minimal distance of all those candies in that station, right? And the second part is we iterate through all of those starting locations. So we are going to calculate the final answer for each of them. So let's say we start from the first station, and the answer is initial value is 0. And this is going to be chosen based on the longest time cost, right? And we iterate through all of those stations and find the maximal time cost. So for each station, if there is a candy in that location, we're going to calculate the time cost for that station. So the time cost has three parts, right? The first part is this part. This part is the time cost for the train uh, move from the starting point to the target station, right? Because during that time, the train doesn't have candies in that decision. It cannot pick up nor can drop off, right? So we need to add those time into the um, total time cost. And the second part is the number of full circles we are going to have for this station, right? For this station, we are going to have two candies, so we need to cover one full circle, right? Because 2 minus 1 is 1, so we need to cover one full circle. So we move from here, 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 and reach the uh, target station. And we are going to move the nearest candy, right? So the last part is the time cost to move the nearest candy, which is the minimal one, right? We saved in the second value. So we add them together is the time cost to move all those candies in the targeted station to the correct stations, right? And we are going to choose the maximal one to use it as the answer. So I guess that's it. Um, hope it can help you understand how to solve this problem. So see you next time.